Hey everyone, this is Mrs. Reister with lesson 7.2, and this is your key for your turn number 1. Here we have for A, negative 5x is less than or equal to 30. So because we have negative 5x, really what that says is negative 5 times x is less than or equal to 30. So to solve this, we are going to do the inverse of multiplication, which is to divide, and we're going to divide by negative 5 on both sides. Now recall from your notes in the earlier videos that when we divide by a negative on both sides, our inequality sign reverses. So now we have, rather than less than or equal to, we have greater than or equal to, and 30 divided by negative 5, well, 30 divided by 5 is 6, and a positive divided by a negative is a negative. So my inequality solution here is that x is greater than or equal to negative 6. So now on my number line, I'm going to plot my point negative 6. And to the left of that, I've got negative 7 and negative 8. And to the right, I've got negative 5 and negative 4. So I'm going to put up my circle at my boundary of negative 6. And because it is also equal to, it also includes negative 6, so I'm going to fill it in. And then I'm going to draw my line to show the values that are greater than negative 6. So it's going to go to the right. For B, we have 4y is greater than or equal to negative 4y is greater than or equal to negative 32. So I'm going to divide by 4 on both sides. And because I'm just dividing by a positive, my inequality sign remains the same. And negative 32 divided by 4 is a negative 8. So I'm going to do the same thing. I'm going to create my number line. And here I've got negative 9 to the left, negative 10. Negative 7, negative 6. Make my circle because it's also equal to. I'm going to fill this in again. And my line is going to go to the direction of values that are greater than negative 8. So my line is going to go to the right. And now for C, negative 10 is less than or equal to negative 2.5h. So I'm going to divide by negative 2.5 on both sides. So on this right side here, on the right side, I have just h. And then because I'm dividing by a negative, my inequality sign flips. And then negative 10 divided by negative 2.5 is positive 4. So I'm going to put 4 on my number line. And then I've got 3 and 2 and 5 and 6. Put my circle at 4. I am going to fill it in because it's also equal to. And my inequality states that 4 is greater than or equal to h. So 4 is the greatest value because it's also equal to. So my line in this case is going to go to all the digits in which 4 would be the greatest value. So that's going to be all digits less than 4. So my line here is going to go to the opposite direction toward the smaller digits. Now we could also take our inequality of 4 is greater than or equal to h, and we could also rewrite that if you would like. So that would also be another inequality that would be the same, but we could write that differently by flipping h and 4. So rather than having h on the right side of the inequality sign, we could move h to the left side. And if we flip-flop our h and our boundary, then our inequality sign also reverses again, to which it would be less than or equal to. So both of those would be sufficient. And now for D, we have 46 is less than 10p. So I'm going to divide by 10 because I'm just dividing by a positive. My inequality sign stays the same. And 46 divided by 10 is 4.6. So on my number line here, I'm going to have decimals. So I've got 4.6. To the left, I've got 4.5, 4.4, 4.7, and 4.8. My circle at 4.6 is going to be open because it's not equal to. And then just like I did in part C, if it works easier for you, if you feel more comfortable seeing the variable on the other side, you can rewrite it. But keep in mind, if you reverse your boundary and your variable, your inequality sign must also change. So 4.6 is less than p, which is also the same as saying p is greater than 4.6. So because p is greater than 4.6, my line is going to go to the right to all the values in which p would be a value greater than 4.6.